Okay, for practice test 3, REX, we are asked to prove that WER is congruent to XEQ. These are vertical angles. We are going to be proving the vertical angle theorem by doing this. And so the way that this proof starts out is that REX and XEQ are supplementary. So those two angles are supplementary. That is because they form a linear pair. Because they are supplementary, their measures sum to be equal to 180 degrees, so measure of angle REX plus measure of angle XEQ is equal to 180 degrees. For the next linear pair, we do need to look at the line below to see what pair of angles it's referencing. It's WER and REX. So WER and REX, that's these two angles over here. So they share this angle. So we are going to say that angle WER and angle REX are supplementary. They are supplementary, they form a linear pair. That means they're 180 degrees because of the definition of supplementary. Now, because that is equal to 180 and that is equal to 180, they must be equal to each other because of the transitive property. So measure of angle REX plus the measure of angle XEQ is equal to the measure of angle WER plus the measure of angle REX. Now, we can see that we have the measure of angle REX on both sides, so we can subtract it to be left with XEQ and WER. That is subtraction. And then we are going from equal to congruent by definition of congruent, so we have angle WER is congruent to angle XEQ. And that's it. Moving on to the next one, we are given that the measure of angle, that angle MUQ is congruent to angle JID. We are going to need to change that to be a equal statement instead of a congruent statement. So measure of angle MUQ is equal to the measure of angle JID. Let's mark that on the figure. We are asked to prove that angle QUW, it's hard to see, QUW, I marked the wrong angle, didn't I? MUQ. MUQ is congruent to JID. I had the wrong one marked. We are asked to prove that QUW is congruent to DIH. So the way we're going to do that is say that both of these pairs of angles form a linear pair, that these two angles are already known to be congruent, and if they both form 180, then whatever is added to them to make them form 180 must be the same, which would mean that they are congruent. So moving on, we are going to say that JID and DIH are supplementary because they do form a linear pair. That means that their measures sum to be 180 degrees. So measure of angle JID plus the measure of angle DIH is equal to 180 degrees. We need to look here to see what angles are being referenced for the next linear pair. It is MUQ and QUW. So angle MUQ and angle QUW are supplementary. because of linear, they form a linear pair. That's this pair right here that form a linear pair. Their measures sum to be 180 degrees because of the definition of supplementary. Now the transitive property, because this is equal to 180 degrees and this is equal to 180 degrees, they must be equal to each other. So measure of angle JID plus the measure of angle DIH is equal to the measure of angle MUQ plus the measure of angle QUW. Now this gets a little bit tricky for people because there is nothing on both sides that appears to be the same right out of the gate. There are two things that are the same because MUQ and JID are equal. That means that I can subtract JID and MUQ from both sides, and I will be left with DIH and QUW. So you'll see for that 7th step in the proof, we have to go back to step 2 to be able to subtract that piece out, or those pieces out. Now their measures are equal, so they must be congruent. That is definition of congruent. So angle DIH is congruent to angle QUW. Moving on to the next page, we have that given angle GAW is congruent to angle BEX. And angle WAH is congruent to angle XED. We are going to be asked to prove that GAH is congruent to BED. So what we're going to do is say that these two are congruent, these two are congruent, and that if I add these two up, I'm going to get the same thing that I would if I was to add those two up. That's how this proof is going to go. So we begin with our givens. That first one was a given. Angle WAH is congruent to angle XED. Measure of GAW is equal to measure of BEX. That is definition of congruent. The other pair is measure of angle WAH is equal to the measure of angle XED. Also definition of congruent, you can see that this statement came down here to create that one, and this statement came down here to create this one. Now it looks like we are adding BEX and XED to form BED, that is angle addition. Then we are also going to do the same thing for the other pair of angles, angle GAW plus the measure of angle WAH equals the measure of angle GAH. So now we need to be looking at these two rows, and oops, not that one yet. We need to look at this row and this row and see what's going on. It looks like GAW is the same, GAH is the same, WAH is getting replaced with XED. So coming back up to this row, WAH is replacing XED. That is substitution. And for the next step, we want to notice that GAW and WAH is equal to GAH. GAW and XED is equal to GAH. They are both equal to the same thing, so they must be equal to each other. Measure of angle GAW plus the measure of angle WAH is equal to the measure of angle GAW plus the measure of angle XED. Okay, and we can see that those both have angle GAW in them. we can subtract angle GAW. And I'm not getting what I wanted. Let's go back and try again. That did not produce the result I wanted, so we're going to try something else.
Please excuse this interruption.
Okay, I think I see what needs to happen. So we replaced WAH with XED. We need to replace GAW with BEX. So BEX plus measure of angle XED equals measure of angle GAH. Now what happened there is that I noticed that GAW and BEX were equal, so GAW is getting replaced with BEX. Now, and again this is a super tricky one, now since BEX and XED are there, and BEX and XED are there, we can say that since BED and GAH are both equal to BEX XED, they must be equal to each other. Oops, and that is, in that statement that's next, that is the transitive property. Last, we would be going from measures to congruent statements. Angle of BED, angle BED is congruent to angle GAH. That's a tricky one and a tough one because of the way that the transitive property is used. Last one, we are going to say that we are going to prove that QED is congruent to MEX. And what we are going to use to do that is DEM and MEX are supplementary. So these two angles are supplementary. That is a linear pair. We are asked to produce the other linear pair, which is going to be this pair down here, QED and DEM. So these two. That means they share this angle. So the other linear pair is going to be angle QED and angle DEM are supplementary. Now this statement is going to come down here. For a measure statement, measure of angle DEM plus measure of angle MEX is equal to 180 degrees. Because of definition of supplementary angles, this statement is going to come down here for that statement, and for the same reason, definition of supplementary. Now, we see that those two angles added together make 180, those two angles added together make 180. If they're both equal to 180, they must be equal to each other. That is the transitive property. And we see that they have DEM on each side, so we are going to subtract DEM from each side. We are left with measure of angle QED is equal to the measure of angle MEX. Now we go from measure to congruent. By definition of congruence, angle QED is congruent to angle MEX. And that's it.